So in this video, we're going to look at triangles with equal angles. So I've drawn a couple triangles here with side lengths A, B, and C. Uh, and all of these angles, this angle is equivalent to this angle, this one at the top is equivalent to this one at the top, and this one here is equal to this angle. And what we're going to see that is if we scale the base by any factor that's greater than 0, any real number that's greater than 0, we will see that we also get the side length corresponding to the A scaled by that same factor of k, and also the side length C scaled by the same factor of k. So let's quickly take a look at why that is. So here's the triangle with the A, the B, and the C. And what I've done here is I've drawn an exact copy of this triangle and placed it right here. So it's an exact copy. So therefore, these are congruent triangles. So in this case, the k is 2. We've extended the base to 2. And we want to know what happens with the A's and C's as we complete this triangle. Well, all we have to do is rearrange the A's and the C's by putting this A over here and this C over here. And now we can see that, in fact, what we have is 2 A's for this side length and 2 C's for this side length. Now, you might be wondering, well, how do we know that they will meet at exactly at the top at that point right there? And the way to see that is to first note that each A and C project onto this base here. So when we take this length here and this length here, together they will combine to be one of the bases. So basically A plus C plus A plus C is the same thing as A plus C plus C. Each copy of these A's combined with a copy of these C's will cover one of these bases. So if we have 2 of them, it'll cover 2 of these bases. So we can't have a situation where they won't meet. Now you might be wondering, well, what about the height? Like maybe, okay, so maybe, the A comes up to here and the C does come up to here so that we have a line here so that 2 of the bases are covered exactly by the 2 A's and the 2 C's, but the heights would be different. That can't be the case either, because the best way to see that is to look at this triangle here as a little mountain. So we have the base, and we can get to the top of this mountain by going the steep route along A, or the longer route along C. But either path that we take, we'll still get to the top of the mountain. So therefore, when we have done this twice, 2 of these A's, that will be exactly 2 of these mountains. We will be exactly at twice the elevation as we would be here. But that's the same thing for C. So we can't have 2 A's and 2 C's at different elevations, because they each have to be exactly at twice the elevation of one of these little mountains. So I've used a scale factor of 2 here, but remember the k can be anything. So I could let k be 100, and we could literally put 100 of these congruent triangles next to each other, and then we could just rearrange all the A's, and we would have 100 of the A's to get to the top of the mountain, and we would also have 100 of the C's to get to the top of the mountain. So as a result, we would see this here, that when we scale one side by a scale factor of k, it also scales the other two sides by that same scale factor. So in fact, we do get a triangle like that. And what are these triangles called that have all their angles equal and therefore their corresponding sides and proportion? These are called similar triangles. Thanks for watching.